Assalamualaikum guys, welcome back to the channel. Guys, today inshallah we will cover up the second algorithm that is called the Kruskal's algorithm. We discussed the minimum spanning tree and we discussed before that there are two methods to find out the spanning tree. One method we discussed in the last video that is called the Prim's algorithm, and today we will inshallah cover the Kruskal's algorithm. So steps. First of all, for every algorithm you need to solve, you need to follow the steps. Okay, without steps you cannot solve any algorithm. So steps are same for the Prim's algorithm, but first of all, let me show you where are the steps. Yeah, these are the steps which you hope so you can see on the screen. That step number one is that whatever the graph you have given, you remove all the loops and parallel edges from the graph. You need to remove all the loops. What is the meaning of the loop? Let's say we have this vertex A and it has the self loop. This is called the loop. And what about the parallel edge? Like say AB, we have this one and we have, let's say again this one. This is now the parallel edges because this goes from A to B and then B to A back. This is called the parallel edges. So you need to remove all such loops and you need to remove all such parallel edges from the graph. Now the step number two says that if two parallel edges are present, then which edge you need to select? You need to select such edge which contain the minimum weight of cost. Simple step. Step number three is step number three is same. Then you have to what is the step that you have to arrange? I have there. Yeah. Step number three that in Kruskal's algorithm, what you need to do, you need to arrange all the available edges according to their edge weight in increasing order. What is the meaning of the increasing order? Let's say you have the edge for three. You need to write this one, two, three, four, five, six. Okay, from lowest to highest. This is the ascending order. So you have to select such edges according to their weight or cost in increasing order. Okay, it will never happen that you have written four and then five. No, sorry, four and let's say four and three. No, this is wrong. You need to write the three, one, and then four in increasing order. Okay, your number is always increasing. If your number goes to decreasing, then you are doing incorrect. So this is the simple steps you need to follow in the Kruskal's algorithm. So I'm just moving to the algorithm and try to solve that. So let me five. Yeah, I have opened it. I hope so. Screen and everything is visible to you and you are seeing everything. So what I need to do, I have, as you see, this is a graph which I need to solve using the Kruskal's algorithm. So step number is one. What we need to do, we need to remove all the parallel edges from the graph. So first of all, parallel edges and loops. So we need to check that where are the loops and where are the parallel edges present. So if I check, if I scan this, this first one loop is created. This first one loop is present. Okay, this loop actually which I am highlighting, this loop is present. So I need to remove this loop and this parallel edge is also present. As you see, A and B edge is present, but B to A also edge is present. So we do not need this one. As the parallel edges are present, so we discussed that you have to select such edge which has a minimum weight of cost. So minimum weight is 5. So we need to select A to B, not B to A. So I'm just making the graph again. F. Okay, then we need to do with the A. Okay, then we have with the C, then we have with the D, okay, and then we have with the E. Once I have added with the E, and then here from A to B, we also have a edge. So A to B, and now I'm connecting this one. B to E is weight is 4. Okay, D to let's say E weight is here 1. We have a weight 2, and B to D we have a weight 2, and then same like with B to C we have a weight 6. Okay, C to D we have a weight 3. F to C we have a weight of 8. F to A we have a weight of the 7, and which edge is left? A to C. Yes, which weight is 3. So this is what I have created. I have removed all the parallel loops and parallel edges from the graph. Now it's a time to solve this one. First of all, you have to take such edges which have the minimum cost. You have to write all the available edges in their increasing order. So I'm just writing one by one. You have to follow me. So what I need to do first of one, I need to check that which edges contain the minimum weight first. First of all, we need to, as you know, 2 is smaller as compared to 3, 4, 7, 8, okay, and 6. So first of all, we have the weight. We need to write in the increasing order. We remember. So weight B to D. This is the smallest one. So I need to write B to D weight is, let's say we have 2. I write it. Then you need to check D and E. Okay, D and E both have the weight same. So I need to write D to E as well. Okay, if you remember, if you have two, let's say, two edges or two vertices, sorry, which have the same weight, then you have to write the both. You do not need to write only BD and you just neglect this DA. No, you need to write both one. Okay. Then we have the edge which have the weight smallest 3. 3 is the smallest than one. B to D. So I need to write then A to C, which weight is, let's say, and the weight is 3. Then we need to select such one which have the cost minimum, that is B to E. So B to E I am also writing which have a weight 4. Okay, then we have A to B which have a weight of 5. Sorry, I have not mentioned this one. This have a weight 5. Okay, so A to B we have a weight of 5. So A to B we have created this one also. Then we need to draw the BC. BC weight is, as you see, B to C edge weight is 6. So we need to draw as well. B to C we have a weight 6. And same like A to F we have a weight for 8. If we have a weight for 8. So A to F, A to F we have a weight of 7. Sorry, not 8. And we have one more left, that is called F to C, which weight is 8. So here I have written all the edges according to their increasing order. I have written in increasing order. See, first of all, 2 will come, then 3 will come, then I have written 4, then 5, then 6, then 7, and then 8. So this is the increasing order I have written. Now it's a time to draw the Kruskal algorithm. Okay, I have written, see, I have written all the edges according to their cost in increasing order. Okay, so we remember one thing more I need to add before making this graph by using Kruskal algorithm. You need to remember that while connecting the edges, now we need to connect the edges. So while connecting the edges, there will be no cycle. If the cycle is present, then you have to remove that edge. Okay. So I need to draw. Now, first of all, I am just starting from the smallest ones from B to D. This one I am starting. I need to draw. So B to D, I am drawing. B to D, okay, I am drawing. B to D, I have drawn, which have a weight of 2. So I have written 2. Then we have, if I say B to D, then we have next thing, that is D to E. So here I'm creating only the E section because D is already present. So D to E, we have a weight again 2. So I need to write here too. Next we have A to C. It means that we have to write A to C. So let's see, I'm creating here one. A to C. Let's say I am writing here. Okay. A to C I am writing here. So A to C we have a weight of 3. So I have written 3 as well. Next thing we have B to E. Can I connect this B to E? Now the question arises, B to E, I need to connect this one. No, if I connect B to E, then this will make a cycle. How it makes a cycle? See, this one is going here and same one is going back to the original place. So this cycle is making. So I said before that if such edge which is making the cycle, so you do not need to add. Okay, it will disturb all of your things. So what I did, I remove this. Okay, so I do not select this one. So I'm just putting a cross on BE because this is making a cycle. Next thing we are moving A to B. A to B which is making 5. So should we select this one or not? If I am selecting this one, B, sorry, what is the next one? A to B. So will we select the A or B or not? A to B. Will we select or not? Let's check it. If I make to B to E, okay, it will again make a cycle B to E5. As you see, cycle is making. B to E. Okay, cycle is making. So I am not considering A to B. Okay, then it is making a cycle. So we are not selecting A to B. Okay, sorry, A to B we are selecting. Okay, because it is not making any cycle. Okay, sorry, I'm sorry for that. B, A and B we are considering because it is not making any cycle. So we have ticked this one. So A and B we have selected with the weight of positive 5. So B is not making a cycle. Now the question arises with the B and next thing with B with C. Can I connect B with C? No. If I make now connect, it makes a cycle. So I do not need to add this one B to C. B to C makes a cycle. So what I did, I just want to remove this BC as well. Now the question for A and F. Will I connect this A and F? Yes, A and F I am connecting because F is not present. So let's say here this one is F. Okay, just remove this one. Here A, I connected A with F, which have a weight of 7. Okay, so this is what I have connected A with 7. Last thing with F with C. Can I connect this F with C? No, it is making a cycle. So it means that we do not need to add with F and C as well. Okay, so this is not what we did. We do not need to add with the F and C because it is making a cycle. You have to remove all such edges or all such vertices which are making a cycle. So according to this one, your Kruskal graph is looks like this one. Okay, this is your final Kruskal graph using Kruskal algorithm. Sorry, your minimum spanning tree using the Kruskal's algorithm. Okay, so this is, as you see, it is not making any cycle. So that's why I am not considering this one. Okay, A to B. Okay, B is already present. So this is how this is not cycle is working. Okay, so this is how you find the minimum spanning tree using the Kruskal's algorithm. Okay, so this is how it works. Okay, it never contains any cycle. As you see, everything is fine. This B to C, then C, and then we have A to B and this one. Okay, as we have visited all the vertices. Okay, we have the A. Okay, we have visited, sorry, F, we have visited the A, we have visited the C, we have visited the B, D, and E. Okay, and we have visited the F as well. So all the vertices we have visited. So this is your final Kruskal graph, sorry, minimum spanning tree using the Kruskal graph. This is what you have to understand. Okay, so very easy steps are very clear. You just need to arrange the given vertices according to their increasing order. Once you make, just draw the edges and remove such type of vertices which are making cycle, because the cycles are not allowed in the cycles are not allowed in the Kruskal algorithm. So you just need to remove the cycles. Okay, you have to remove the such vertices which are making the cycle. So I hope so guys you like this video. If you like this video, kindly do like, subscribe and share. Meet you in next video. Take care.